You know how you can use React.memo, useMemo, use callback hooks to optimize React rendering performance, and how all that is just a pain in the you-know-what. Well, React compiler just reached release candidate. What does that mean for everyday Joes like you and me? Well, nothing really, except for the fact that we can completely forget about all those optimization hooks. Not only that, recently React came out with a blog saying that the React compiler will also take care of dependencies for use effect hooks and have the whole process automated. For those who are vibe coding, congratulations. Now you can give even less about how you vibe code. But in all seriousness, you definitely should check this out. I think this is the way React will be moving forward, and it's gonna prepare your code base for what's to come. Just give me a few minutes of your time and I will promise you won't regret it. I will show you how to get this set up in your current or a new React project. It is super easy, a few lines of configuration plus an install command, and you're done. Like seriously, really quickly. So what's all this fuss about the React compiler? Like, what is it and what does it actually do? The React compiler is a build time tool. Basically, it takes your React code and then outputs an optimized version of it by memoizing components and hooks that can be memoized, specifically components and hooks that follow the rules of React, where it states components and hooks must be pure. React calls components and hooks. Not sure why you would ever call React components or hooks outside of React. Yeah, if you're one of those people, please let me know down below in the comments. I'm really curious. And then the rules of hooks, whatever this is, even I don't know. Only calls hook at the top level. Like, why would you call hooks in a nested function or inside a loop? Only call hooks from React functions. Yeah, well, I don't even know if you can call hooks outside of React functions. Interesting. Well, basically just write normal React code and then the compiler will take care of the rest in terms of optimization. But what happens if some of my hooks or components break this golden rules of React? Well, guess what? The compiler will just skip over those components or hooks and not optimize them. That's the extent of the punishment you'll get. You may be asking, what happens if I'm already using the React optimization hooks myself? Will the compiler do anything? No, the compiler will not touch that code. It will not give any errors, so you're still good to go. The two areas that the React compiler is focusing on right now is to minimize the re-rendering of child components when parent components renders. The second area of focus is skipping expensive calculations from outside of React. So for example, if you have a really expensive operation for whatever reason, like searching through a very large array inside your React component, React compiler will try to memoize that if it can. Here I have a really simple table that I created previously in my table column resizing tutorial. This is a Next.js project, and I will bring it up right here. I'm not going to go too much into the code of this table. Basically, it uses TanStack table and Shadcn UI. What I am going to do is I am now going to be adding the React compiler to this Next.js project. But before that, let's take a look at the table and see what are the performance issues we have here. The moment you can see, the moment we resize, everything re-renders. Like literally everything is re-rendering. It's actually chugging. You can actually see if I turn off React Scan, you can also see that it's like not as smooth as it could be. Obviously, this only has 10,000 rows. Yeah, I know 10,000 rows. But it's also, if I drag this, it also chugs really, really hard. Nothing here is memoized. I'm just as curious as you. What would happen if we added React compiler to this project, and let's see what it actually does. Does it actually memoize these components so that if I resize one column, not everything in the table will re-render? Well, let's add React compiler now then. You're going to want to install the Babel plugin React compiler. On top of that, I also recommend installing the ESLint plugin. This will help you make sure that your React code is following the rules of React. Once you have those installed, go into your next.config.ts file, and you're going to want to just add this experimental flag. So let's go ahead and add that here. And that's basically it for us to be able to use the React compiler. If you are working with a Vite project, you can add the React compiler like so. Now all we have to do is just run the project, and the compiler should work automatically. Not sure if you're able to see this now, but when I resize the column on this table, it's actually really buttery smooth now. And you might be thinking, oh, that's great. That's it, right? That's all we have to do, and everything's like sunshine, and yeah, my React app is now 10x faster. Tisk, tisk, tisk. Well, if you thought that, think again, because look what happened. Oh, what is this? Why is the table like acting weirdly? Like I am dragging, trying to resize, but the cell columns are not resizing with the header. Weirdly resizing. This is a few caveats and bugs that React compiler introduces, and I'm gonna show you in a moment how I go about debugging that. Well, how do I know which React component is being optimized by the React compiler? If you have React DevTools installed, just open it up, go to the Components tab. You'll be able to see this memo badge. And if you hover, you'll even be able to see the tooltip. This component has been auto-memoized by the React compiler. And if we go look down at our table, the table had basically quite a bit of components in this tree is being memoized. In fact, a lot of it is being memoized. If you're curious about how fast your application has become after you have applied React compiler, you could profile it. So here, I'm just going to profile the application here and then start resizing. Okay, great. And then I'm going to let that go. And then we can take a look real quick, and we can look down here. The table, look at how many things has been memoized. A lot. And it's taken about 34 milliseconds. Overall, this frame took, 34 milliseconds to render. So keep 34 milliseconds in mind. Now, we're going to go back to our application, and we're going to turn the React compiler off. You can immediately try resizing, and you'll notice this already, like the lag is coming back. But notice how when we resize the column down to very small size, it's behaving as expected. Okay, so I'm clicking profile, and then I'm just dragging. Okay, enough. Cool. Already we are now at 106 milliseconds without the React compiler, and with the React compiler, it is 34 milliseconds. So there is a significant speed up, and you can see here, like everything here is being re-rendered. There is no memoization happening right here at all. There are two workarounds that I can go about using in order to fix the table column resizing issue that we were having when React compiler is turned on. The first one is if we specifically mark each component that we want the React compiler to optimize. To do that, we just need to add the compilation option and set it to annotation under React compiler. And then we just need to mark each component that we want the React compiler to memoize and optimize with the useMemo directive. The other way would be the vice versa. So we would use the useNoMemo directive instead of useMemo, and we would keep the React compiler option set to true. In this case, because I already know which components are the offender that causes this column resizing issue, I'm just going to use the useNoMemo directive. So here I've marked the default cell and default header to use noMemo. And as you can see, now when I resize, it works as expected. If this video was decent and you enjoyed it, please consider giving me a like and subscribe. It really helps me out. Anyway, I hope you have a wonderful day. I'll see you in the next one. Peace.